Hi everyone, thanks a lot for watching this video. In this video, I would like to present you a feature that exists in Hyperview, which is the loop results feature. This feature is available in the report tab. When you click on the results icon here, it's available in the list of modules that pops up. So when you click on loop results, it's added in the report browser. The idea of this loop results feature is to loop a particular post-processing strategy over different components and different time steps. So let me show you an example. Let's consider this very simple use case of a cantilever beam here that you can find. Just to show you how this beam behaves, it's fixed here on the green bolt, and there's a force applied at the right hand of the beam. So if we look at it, this is how it displays. So imagine I would like to get the maximal stress in the different components of this model at different time steps. Right? I can look at the contour and display it by selecting different components and looking at the maximal stress at different time steps manually. But the idea of loop results is to do this automatically. So the first step is to select the contour I'm interested in and apply it to the model, right? So you can see how the contour evolves during the time. Then I will click in the loop results, and this gives me different options. The first option is to select the components I would like to loop this post-processing strategy on. So I can perform it on all the components, or I can select the components I'm interested in. So for example, these 3 components, and when I click on proceed, you can see that the ID of the components are gathered in this field. I can also apply the strategy to all the displayed components. For example, to have an ID of the maximal stress in the whole model. So in my case, I'm not interested in that, and I only want to have a look at the selected components. Then I can have a look at different load cases. In my case, it's a radial simulation. So the load cases are the different time steps. So I could apply the strategy only to the active time step, at the last one, at all of them, or at some multiple time steps, which gives me the possibility to choose which one I'm interested in. So for this example, let's consider every 5 milliseconds. So I'm selecting manually the different time steps I would like to post-process. Then I can exclude some entities if I want, and I can specify how I want my loops to be performed. So I can start loop with components or load case. The difference is if I'm starting the loop over the components, for the first time step, it will loop over all the selected components. Then for the second time step, it will loop over all the selected components, and so on. If I'm selecting load case here, for the first component, it will loop over all the selected load cases. Then for the second selected component, it will loop over the selected load cases, and so on. So in my case, I'd prefer to stick for the first load case and look at all the components, then look at the second load case and look at all the components, and so on. So this will create a table with the different maximal values for the different components. So if I'm running this, it's looking at the maximal value for all the different components at all the different time steps I have selected, and it will gather the results in a table. So as an output, we have this van Mises scalar value, which is a table, and if I'm having a look at it, you can see here that I have all the different time steps I've selected every 5 milliseconds, and for all these time steps, I have the maximal value of the 3 different components I've selected. That's a good first point, but then I could be interested in having a look at where this maximal stress is located for the different time steps and the different components. So I will delete this result and I will add an item to my loop results feature, which is a picture. And I will ask this picture to display the maximum of the contour I've selected. So here in the node, I will create a node to specify the value of the maximal contour and its location. I have some options, so I can ask for the legend. If I want to export a report afterwards, I can specify how the legend is written and where it's positioned compared to the image. So I can position it below the image or above the image. And I can also change how this legend is written. So here, for example, for every picture, if I export a report, I will have the following legend, which will be loop results hyphen name of the component hyphen name of the subcase label. So in my case, let's say I don't want to have loop results written for every picture. I just want the name of the component, and instead of the subcase label, let's say I'm interested in the time step. Sorry, simulation title will be the time step of the current picture. Okay. I can also ask for a dynamic legend to be used. Otherwise, I will I won't have the legend scale that is adapted for every picture. Right. So if I'm running this loop results again, I will have the same table as before, and on top of that, for every maximal value that is in the table, I will have an associated picture that will display where this maximal value is located and also its value, even if I already have it in the table. I will also have it in the picture. So that's the same table as before. Here, a table that gathers all the maximal value for the different parts at the different time steps. And I have a picture for each value of the table. So here, for example, the block component at time 5 milliseconds. Here the maximal is 0, so all the elements have the same value. But if I'm going to the first time step that's relevant, for example, here at 10 milliseconds, for the both section part, the maximal value is reached here, and its value is 0.092 megapascals. Here it's the same for the block component or for the bolt component. And I have it for every time step that I've selected. So if I want, I can export this report by clicking on the export button here, which will allow me to export it anywhere I want. So for example, if I'm creating a report live, for example, this will generate a report with all these pictures and this table, and it will open up when ready automatically. So here you can see that the report has been exported, and now that it's ready, it will be opened automatically. So it's not opened in the window, but here is the report. So report underscore live that's just been generated. So you can have some summary items that you can, of course, customize here. But what's of interest in our case is the table gathering all the maximal values for the different components at the different time steps for the Van Mises contour. And you can see the pictures of every component at every time step with the maximal value and the legend as we have created it. So the name of the component, here it's bold section, and the time step at which it's been taken, so 5 milliseconds, and you have this for every time step. Of course, you can see here that the note is not very easy to read, so there are options in Hyperview if you want to change how this note is written. You can click here to change the note format, change the size of the text and the color of the text, and so on, to customize your report.